Okay. Let's take a moment to really think about it real hard.
So, the other day, I was doing my daily browsing of Wikipedia when I found this. It represents a four-dimensional cube or tesseract undergoing a rotation along both the X, Y, and ZW planes simultaneously. This completely boggled my mind, and I just had to simulate it. First of all, let me point out that the visualization is not four-dimensional.
Alright,
Rather,
so what do
it
we
is a
begin with
representation
here?
of four dimensions
Now,
in
there's
three
a lot of
dimensions,
divergent...
and it is then rendered on a two-dimensional
There's a lot of
screen.
Eulers,
What does this
Engling
mean?
angles
Well,
involved with this, but let's begin with first the world.
I mean, it's no
The world.
four-dimensional cube or anything,
The United
but it'll do
States.
for now. We can represent this cube as a series of planes
New
or
York,
cross-sections cut along the
Delaware
X, Y,
County,
or Z axes.
The town of Hancock,
Obviously,
or
the
the
2D
village
planes
of
are not
Hancock.
actually 3D cubes. Rather, they are representations
The
of
town of
3D
Hancock.
objects in a 2D space.
Okay.
If we take
And
two planes,
at
one
any
at
point in
Z,
time,
negative
and I
0.5,
said
and another
time,
at Z
X,
equals
Y, Z,
positive
and T,
0.5, and
they're going to
connect these
tell
two
me it's
planes with
rotating on
lines
the
that
W
represent
dimension
all
as
other
well.
possible
Well,
planes
back to
along
New
the
York
axis.
State.
We once again see a cube. This
Here
is
I
kind
have
of
the
visualization
cost
we'll be
of
doing
one of these
for our
counties, but I
4D
have a lot of
test.
roads rolling
If we take a
through
cross-section
multiple
along
counties
the
at the same time,
W dimension, let's say
infrastructurally.
that W equals
I'm sure they all have a
-0.5.
bridge,
We'll find a
but if the
three-dimensional
budget
cube.
is different
And if
from
we
one
move
to the
along
next,
W
I mean,
dimension from W equals negative 0.5.
let's just go ahead and 300 yards, 3 inches, something like that. So we'll be getting into land nav and what is the other term? I forget what it's called. OPORD briefs.
We're going to get familiar with a military map.
See, I do all mine binarily. You have to use some kind of code sequence, whether it be SCAL, a hash for the river, a heavy line that's segmented for the highway, indicated main lines. There's cricks inside of
We have
here.
to familiarize ourselves with it.
A lot of there's topology features. You know, you're not really going to know any of those things at this scale.
The addition,
And then we're going to actually keep taking this down a little bit farther. Here I've kept IH at all points and times on the map.
An operation or you're working with
Where are we?
on the same
Sorry.
sheet. Heard the phrase in the past, same sheet of
Where
music.
is it? There it is.
This is it.
That's IH.
Then you go to the
We
legend.
obviously have
What the
IH
legend is,
over
it
our
articulates
Vitruvian man
what
here on the
physical
scale of the
man-made
ball.
structures are on
The
this
rotation
map,
here.
which will be able to be picked out by
We
the
got
symbology that
IH
is
in-
reflected in the legend. Buildings, churches,
In New York.
cemeteries, mines,
I'll
or active or
have
inactive mines,
IH
power lines, railroad lines, etc. Military
In New
overprint
York.
information tells you
I
where the
have
impact areas are, which is a no-go. We don't go to impact areas.
IH in both of
Your
the
slope guide, your elevation guide,
in both
your
of my
adjoining map
county
sheet.
and
Very
road
important
models,
so that everybody
and I'll
that's in
have
your unit
IH
and
in my
adjacent
physical
units know where you're
location
working at it, and it's important
as we're
for
working our way down to
information
me,
going
the
back and forth to know
Vitruvian
who's on the
me,
left and right
this
side of you.
type of
Down here you
object
got
at
your
the
three norths
W
depicted on
function
the
where
map. True
X, Y, and
north,
Z,
which is
you, me,
defined
and
as a
everybody
line
else
from any
until
point
there's
on the Earth's
there's
surface to the
a
North
difference
Pole.
in the packet
Your
to
grid
an
north,
ideal
depicted by
gas
the north-south grid
or an
line,
ideal
is
particle.
established by
As
using
an
vertical
ideal
grid lines in a
gas,
map. Magnetic north is
it's
the
a
pole
perfect
of the
ball.
magnetic field
Okay?
north on your
And I really want you to
compass or your
understand
active
that
compass.
each one of these points
Your
are a
scale,
dimension.
1 to 50,000,
If we
very
remove
important.
that dimension
This is
from
for
this
distance
map,
traveled on a map. Comes in
or
kilometers,
we change the
statute
scale
miles, or
W,
nautical miles. Your contour interval.
it's always
The
going to be
contour
X and
interval
Y.
here on this map is 10
They
meters.
are going to be
It's
relative.
depicted by the distance
Miles and
between
meters
each
are
contour
congruent
interval
with
line
two
is
different
10
numbers.
meters. At the top of a mountain,
As we're going
where it
through
ends,
this,
there'll
I
be a
want to be
small
able to
number, 491. That is the
break
highest
this down.
point
We're going to take this
on
all the
that
way down to what is it. I actually have what is a rock inside of here.
Black indicates
Given
man-made object.
what is bluestone natural walls, fireplace walls, tread rock for swimming pools, so on and so forth, that get us into a different subject. But I want to open this up to be a little bit more complicated than just my stone mill models for what this is. You know, obviously, we could talk about just regular rocks, veneer rocks that are even thicknesses for hanging on the wall and things like that. But never once are any of these objects going to just straight transform into energy like that. It's going to go linearly. Pick it out of the ground, put it on a pallet, and then put it to something. Now, what somethings we put that on are going to have a spectrum to it, a very small spectrum, an X, Y, Z spectrum. Most commonly, Y being the first function. X can be used in a value that changes it from a prior step to its position. So those bits and bytes are going to be... well, I don't exactly know how to best describe that statement because I don't think many people do. But as we're building this mapping system, this is an assembly process. Each process is a dimension that you add to it. If I don't add a dimension, there might be a radical difference that it's a product here or it's a product there, but that product can't be this product over here. And it's something I want you to take into consideration when you're listening or studying.
5 to positive 0.5. We'll see that this cube
it's great that you can program this.
Now,
outstanding.
Like
now tell me one thing that you programmed inside here that actually wasn't just a straight line, arbitrary bits and bytes of how this polarized wave function is set up, because we're going to be jumping all over the place, I'm sure.
Now let's rotate it.
See how, look, and I'm not just talking about what information he's covering. Scal is all over the road to maintain proper dimensions for the way this conversation is working. You're going to get into a lot about that, about mission command, OPORD briefs. You're going to get into that about leadership conversations. It's going to distort this and warp this in a black hole, essentially, with lensing properties that's going to eventually get somebody wrapped around it and send them off in outer space, because you're trying to run this simple Jacobian matrix, M1, M2, and Mn, into these values by trying to get some kid to study fourth dimensional or fifth dimensional objects. Globe, world map. We'll just stick with the world map and 2D land for right now, just because I want to be nice with y'all marshmallows. World map, United States map, New York map, Delaware County map, Hancock Village map, I think is what it is, and then the Hancock Town map. So that's world, world, United States, New York, world, world, New York, world, United States, New York, Delaware County, town and village. So did I just run a 6-dimensional object?
The matrix by LW minus W, where LW is the position of the light source